Domain and range, we're going to look at many different types of functions, and we're going to find the domain and range of those functions. Now, let's look at something like this. So let's look at straight lines first. So straight lines. So domain and range, we're going to look at straight lines first. All right. Straight lines could look like this. Y equals 5x minus 3, for example. Do you know what that roughly looks like? Positive or negative gradient. Cuts the y-axis at -3. You know, sort of looks like this, pretty steep, probably a lot steeper than that, all right? Are there any restrictions on what values of x and y you could get? So straight line, domain is all real x, okay, and range is all real y. Are we okay with that? There's no restriction. The line goes on forever in both directions. Actually, while we're here, can you tell me what the x and the y-intercepts are while we're here? So we're going to do domain and range, and we may as well look at x-intercept and y-intercept. Okay, what's the y-intercept of that line? Yep, and what's the x-intercept while we're here? X-intercept means put y equals 0. For x-intercept, put y equals 0, and you get 0 equals 5x minus 3, so x is... So for y-intercept, you put x is 0. Do you remember all that? We did that in year 9 and 10. So for y-intercept, you put x is 0. And for x-intercept, you always put y equals 0. So this is what we're going to do with these functions. We're going to look at x-intercepts, y-intercepts, domain and range. All right? So for y-intercept, put x is 0. Y-intercept is -3. X-intercept, put y is 0. You get 3/5. So I know it's not to scale. All right, so that's a quick sketch of my line. I'm just going to do one more straight line. 3y minus 2x plus 4 equals 0. All right. I can sketch this line by going y equals mx plus b if I want, but why don't I just do, for the y-intercept, put x is 0. Do you get it? Let's go. Y-intercept, put x is 0. What have you got? 3y minus 0 plus 4 is 0. 3y is -4. What's y? Anyone? For y-intercept, put x is 0. What do you get? 3y plus 4 is 0. Y is, come on, -4 on 3. Good. For x-intercept, we're going to put y is 0. So you get 0 minus 2x plus 4 is 0. What do you get? X is 2x is 4. X is 2. So you could quickly sketch that line like that. I'm going to do domain and range in a minute. Just a quick sketch. And that's it for straight lines. So if you want to sketch something in y equals mx plus b form, that's not too hard. You can sketch your y-intercept, you know it's the b. You can find the x-intercept by putting y is 0 as well. Otherwise, you can do the gradient thing, but you don't have to. I think x-intercept, y-intercept is the easiest way to sketch straight lines, all right? This form, yes, you can put it into y equals mx plus b form by rearranging it, and we will in a sec. But we know our y-intercept is -4 on 3. And we know that our x-intercept is 2, so that line looks like this. Sorry. -4 on 3 and 2. What sort of gradient's it got? Positive. We could tell that anyway by rearranging the equation. Isn't 3y equal to 2x minus 4? So y is 2/3 x minus 4 on 3. I mean, that's the other way to do it. Y is, and now we're dividing through by 3, we've got that. So yes, immediately, if you wanted, you could see that the y-intercept's -4 on 3, which is -1 1/3. The gradient's positive, it's 2/3. Too hard to sketch 2/3 from there, but up 2 across 3. But you can see what the line looks like. What's the domain and what's the range? Domain. Are all values, do these go on forever? All values of x are allowed, so all real x. And the range is all real y. Okay? Now, y equals mx plus b form, equation in general form. Now, what if I ask you for the domain and range? So find the domain and range of x equals -2. The line. X equals -2. So find the domain and range of the line x equals -2. What does that look like? Vertical line. We did some of these the other day. Yep. What's the domain? What's the range? The domain. What values of x do you only seem to have? Yeah. See, this is point -2, 0, -2, 1, etc. So all real, no, it's not. It's just x is -2. And what's the range? Yep, all real y. Remember we looked at these last lesson. And then I could ask for the domain and range of the line y equals 4. Okay, so domain and range of, so we're looking at horizontal and vertical lines. Domain and range of the line y equals 4. Give it a quick sketch. What's its domain? Yeah, this is the x-axis, that's the y-axis. We okay? Domain, all real x, and the range is what? Y is 4. So that's straight lines, domain and range. This is the y equals x squared curve shifted down 3 units. The red graph, y equals x squared. Oops. Okay. Then y equals x minus 2 squared is shifted 2 units to it's the x squared curve shifted 2 units to the right, because what makes inside the bracket 0? X is 2. 2 minus 2 is 0. The green curve, what makes inside the bracket 0? -3. X is -3 is what makes inside the bracket 0. So the x plus 3 squared is shifted 3 to the left. Now all these curves only have positive y values. They all have a range of y is greater than or equal to 0. Their domain, all x values are allowed. Like if I show you, these would go on forever. I know they're very steep and you don't get to them quickly, but they do go on forever. All right, the x values. They're not restricted. There's no restriction on the x values. Now let's look at, get rid of those two, and now let's look at y equals x squared, take away 3. Oops, sorry. Y. Okay, this one. It's the x squared curve shifted down 3 units. Can you see? All right. Y equals x squared plus 4 is the x squared curve shifted up 4 units. You get the idea? All right, let's do those ones for domain and range. All right? All right. Y equals x squared minus 3 and y equals x squared plus 4. Let's go. X squared minus 3 is the x squared curve shifted down 3 units. Oh, while we're here, let's do the x-intercepts. One sec. Let's find out the x-intercepts. What are they? X-intercepts, what do? Put y equals 0. 0 equals x squared minus 3. X squared equals 3. X is plus or minus square root of 3. So it's got nothing to do with the domain and range, the x and y intercepts. Well, the x-intercepts don't with this one, the y-intercept does. All right, so let's go with the domain and range. What is the domain? Are there any restrictions? You know, this just arrows off and goes on forever, right? So domain, all real x, and the range. All right, look at the y values. Greater than or equal to -3. Do you see that? Y is greater than or equal to -3. Let's look at the graph y equals x squared plus 4. It's the x squared curve shifted where? Up 4. Doesn't have to be to scale. Looks like this. Okay, there are no x-intercepts, y-intercepts. There are no x-intercepts. We know the y-intercept is 4. Here we know the y-intercept's -3, all right? What's the domain and the range? Domain? Yeah, it's all real x. Range, y is 4. Now, we'll do a concave let's do a combination. Oh no, it doesn't matter. All good. All right, now, all good. Let's do some concave down ones. Question 5, y equals negative x. I'm going to do a plus 3 squared, make it a bit harder. And number 6, y equals negative x squared plus 3, like this. All right, look at these two. Y equals negative x plus 3 squared. Y equals negative x squared plus 3. We can do the second one first if you want, because it might be easier. What does y equals negative x squared look like? Do we know? Negative x squared. Let's look at y equals negative bracket x plus 3 squared. It is the negative x squared. Inside the bracket is the sideways shift, 3 units to the left. What makes inside the bracket 0? Negative 3. Plus 3 is 0. So it's negative x squared but sideways shift. This other one, y equals negative x squared, negative x squared plus 3, is the negative x squared curve, which is the red one, shifted up 3 units. And then I could do y equals negative x squared minus, say, 2, which is the negative x squared curve shifted down 2 units. All right, so look at the green, the red, and the orange. All right, they are the just the translations up and down. Y equals negative x squared. Then we're going to shift the whole graph up 3 units. And then y equals negative x squared is red, and the orange one is that whole red graph shifted down 2 units. Right, but the blue one is shifted to the left 3 units. Can you tell me the equation? Concave down shifted to the right 1 unit. Y equals what? Shifted to the right 1 unit. It's still negative x wrong way. X minus 1. Yeah. Okay. Shifted to the right 1 unit. Negative bracket x minus 1 squared. All right. Because we look at it from the outside. We say it's negative x squared type, concave down. There's a sideways shift because that's contained in the brackets of 1 unit. What makes x minus 1 equal to 0? X is 1. So it's, because that's what's going to give you a y value of 0 when x is 1. So it's minus 1. The shift is the opposite way. All right. So we're going to sketch these and we're going to write their domains and ranges. All right. All good? So we look at graph 5, we say concave down, shifted to the left or the right. Shifted to the left 3 units, but it's concave down. Shouldn't have drawn it that high. Up here somewhere. Shifted to negative 3. Okay, let's... Oh, while we're here, can we please do a y-intercept? When x is 0, what's y? Well, what do you think it's going to be? It's coming down here somewhere. Doesn't have to be the scale. Yes, it's negative 9. So here the y-intercept is negative 9. The x-intercept's negative 3. Because when x is 0, it's 3 squared is 9 with a negative in front. So there's our y-intercept, there's our x-intercept. What's your domain? What's your range? What values of x are you allowed? All real x. Range. Y is good. This one here, y equals negative x squared plus 3 is a concave. Down parabola, shifted. Up 3. Right. Domain. Oh, what are the y-intercepts, do you think? The x-intercepts, sorry. X-intercepts, we're going to put y is 0. Plus or minus root 3. And domain and range. The domain all real X allowed. What about the range? Y is less than or equal to 3. All right, the last two, you try them. Down, shifted sideways to what makes this 1? I mean, what makes it 0? X is 1. Concave down, I'm going to need, I need a y-intercept. What's the y-intercept? When X is 0, y-intercept is negative 0 minus 1 squared. It's what? Negative 1. Not positive 1. Because it's 0 minus 1 is negative 1 squared is 1 minus 1 or negative 1. All right, domain and range. Oh, over here, what was the domain? All real X, what's the range? Y is less than or equal to negative 2. And the last one, the domain, all real X, and the range, Y is less than or equal to 0. Okay? Sketch these and state their domain and range. Just these two functions will do. Okay, sketch these and state the domain and range. Ready? All right. What would you do first? What is it, concave up? I know what the y-intercept is already. But the thing is, I don't know where the x-intercepts are, and so how are you going to work them out? Put it equal to 0. So let's put equal to 0, work out our x-intercepts. I'm going to have to move this other one down. What have we got? What have we got? So x minus 4, x plus 2. So x is 4 or negative 2. Now, this is good. Let's have a quick sketch. When they're your x-intercepts, we know how to do this, don't we? You know, solve, put equal to 0 and solve. Your x-intercepts are 4 and negative 2. It's concave up, great. What's the y-intercept? Now, we've got to know where the bottom, this is concave up, yes, it goes like this, but do you know where the bottom or the vertex of the parabola is going to be located? It's halfway between the x-intercepts. Okay, so your vertex, so the vertex is always halfway between the x-intercepts. Halfway between the x-intercepts. So, the average of the x-intercepts, so I go negative 2 plus 4 over 2. Are we okay? What's negative 2 plus? That's 2 over 2, 1. So your vertex is located at x is 1. That's the bottom point of your parabola. But how low down does that parabola go? So what we're going to do is substitute x is 1 into the equation of your parabola. And that will give me the y value when x is 1. So how do we sketch this function? We need to know what it looks like. So we need x-intercepts, y-intercepts, concave up, vertex. So what do we need to sketch? X-intercept, let me just write it here. So if you want to sketch, you need x-intercept, you need y-intercept, you need the concavity, you need the vertex. Where's the turning point of the parabola? So the vertex is always halfway between the x-intercepts. So it's 1 squared minus 2 times 1 minus 8, which is 1 minus 2, that's negative 1 minus 8, negative 9. So the vertex is at 1, negative 9. That's the vertex. All right, can you tell me the y-intercept? What's the y-intercept? Isn't that when x is 0? Help. What's the y-intercept? Guys, that's an easy one. When x is 0. Yeah, it's just 0 squared minus 0 minus 8. It's negative 8. It's the constant term. The y-intercept is the constant term. for a straight line and a parabola, the constant term. All right, we've got enough to sketch. It cuts at 4 and -2. The bottom point is 1. The vertex is 1, -9. I'm going to say it's down here. It doesn't have to be to scale. 1, -9. And the x-intercept is, the y-intercept, sorry, is -8. So just going to draw it nicely. See, if the bottom's there, then this bit here is, I haven't drawn that very well. Look, 1 and 4 are just too close on my graph, aren't they? So 1's there, 4's got to be over here. That's better. There we go. There's 4, 1, -9. That's roughly -8 there. Okay, that's the parabola. So let's do domain and range now. So what's the domain? What's the range? So to sketch a function, a parabola, x-intercepts, except for the ones we were just looking at. Some of them you can't work out the x-intercept. These are the ones where you're just given it here in ax squared plus bx plus c form. You have to factorize it to know what it looks like. Okay, so what's the domain? Values of x. Doesn't seem to be any discontinuities anywhere, all real x. What about your range? What's y greater than or equal to? That's right, greater than or equal to -9. Let's look at our next function. All right, concave up or down? Y-intercept. Good. You're going to have to factorize it. How are you going to factorize this one? Take the negative out. You've got x squared plus x minus 2. All right, let's factorize it. Let's find the x-intercepts. Let's write down the y-intercept. We know is when x is 0, you get 2. The x-intercepts we're working out now. Here we go. Example 2. Let's factorize negative bracket x plus 2, I think, x minus 1, yes? So what have we got? We know the y-intercepts too. What are the x-intercepts? X-intercepts are? You know, x plus 2 is 0, x minus 1 is 0, you know, what do we do? So we go x plus 2 is 0 or x minus 1 is 0. So we've got x is -2 and 1. X-intercepts are -2 and 1. Concave up or down? Down. Concave down. X-intercepts are -2. Don't mark in all the points. Just know roughly where they are. Where's this axis of symmetry going to be located? Or the vertex, where is it found? Axis of symmetry is where the vertex is. All right, I'll explain what axis of symmetry is. We did it last year. You know, it's where the vertex is. It is where if I drew a vertical line down here and I folded the parabola, one side would sit on top of the other. It's the line of symmetry sort of through it. So it's called the axis of symmetry. And it's where the vertex is. It's located on the axis of symmetry. So the axis of symmetry, or where the vertex is located, is the average of the two x-intercepts, which is -1/2. Makes sense? -2, 1, of course, it's going to be on the negative side. So -1/2 is where it's going to be, but I need to know the y value. So when x is -1/2, what does y equal? -1/2 squared minus -1/2 plus 2. Be careful. So it's negative, sorry, what is it? Negative what? -1/4, because -1/2 squared is 1/4. So it's -1/4. What's the next one? +1/2 plus 2. Well, isn't that 2.5 minus 1/4? No need for calculator. I'll press 10 buttons to work it out. 2.5 minus 1/4. 2.25. So let's draw. Okay, guys, we might put our 2 is our y-intercept. The axis of symmetry slightly, it's concave down. So we need to know that. So we got concave down. Yes? Concave down. Y-intercepts 2. The vertex is at -1/2, 2 1/4. Okay? -1/2, slightly higher than that point of 2. Do we see? Like this and like this. Okay, what's our domain and our range? This is -1/2 and 2 1/4. I know you can't read that. All right, what's the domain? All real x. Y is less than or equal to 2 1/4. All good?